let's take a quick look at cubic graphs. So a cubic graph is anything that can be written in the form y equals ax cubed plus bx squared plus cx plus d. Okay, now what we're really interested in here is the highest power of x, and we can see here the highest power of x is a 3. Okay, so that means it's a cubic graph. Okay, now let's think about some examples that we could have. So you know, we don't need all this extra stuff here for it to be a cubic. We could have something like this: y equals 2x cubed. That's a cubic. I could have something like y equals x cubed plus 2x squared plus 3. That would be a cubic. Okay, I could have other things. I could have I don't know, y equals x cubed plus x minus 4. That would be a cubic as well. Okay, so basically these numbers a, b, c, and d, you could change it for any number you want, and it'll still be a cubic. Okay, because the thing that makes it a cubic is this x cubed. Okay, so let me delete some of this very quickly. Lovely. Now, if that first term, if that coefficient, that number in front of the x cubed here, if that coefficient is positive, we will have a positive shape for our cubic. And a positive shape for a cubic looks a little bit like this. If my first term, okay, had a coefficient, so this a value here, if that letter was negative, then I would have a negative shape, and so my shape would look like this instead. Okay, I've exaggerated the curves there. Now, if I look at some simple examples, so we could say, let's sketch y equals x cubed. Well, this one looks like this. Okay, it doesn't quite have the same lump in it, does it? Okay, this is a bit smoother. It's got a point of inflection. Okay, that's just a shape that you need to be aware of. Okay, another one here, a negative x cubed would be looking like this. Okay, and again I've got a point of inflection. Okay, so it's not quite the same exaggerated curve there, but you can still see it's quite similar, isn't it? Right, that is a quick look at cubic graphs and what they look like. You need to recognize these shapes. Okay, now what you might notice actually is that if I'm looking at solutions now, so the solutions are where it crosses the x-axis. Okay, that's when y equals 0. So if y equals 0, that's going to give you solution. Now actually it's impossible to have no solutions for a cubic graph, because this shape, however you draw it, it's always going to cross the x-axis at some point. Okay, so we can't do this. There is no way of having no solutions, but we could have a way of having one solution. So let's have a look at what that would look like. So I could have a cubic graph like this. That would have one solution. The one solution is where it crosses the x-axis. There it is. I could have two solutions. So for two solutions, it could go a little bit like this. Oh, it just touches there, doesn't it? So it's crossed here. So I've got one solution there, and here it's just touching. So that one there where it's just touching, that's the repeated solution. I could even have three solutions. It could cross 3 times, crossing the x-axis here 3 times. 1, 2, 3. That's the maximum number of solutions that you can have for a cubic. So you can quickly see, if you have a sketch or you've plotted it, you'll hopefully be able to see very quickly how many solutions there are for your cubic graph.
JoashMaths.